Okay, welcome to this next video for Chem 161, Chapter 1 content, where we'll be discussing temperature conversions. So temperature exists and can be reported in various units. Perhaps you're familiar with degrees Fahrenheit, typically used and dominant in cooking instructions, as well as most empirical resources and textbooks. Degrees C, Celsius as the scale there, is a different set of units, framed mostly by the conditions for water freezing at 0 degrees C and boiling at 100 degrees C. And a more sort of appropriate temperature scale respecting an absolute zero concept is the degrees Kelvin for temperature. Okay, so what we have is equations to convert from one another, and we'll look at those now, and then handle a question and exercise those equations. So if one wants to convert temperature from Fahrenheit into Celsius, we have to use this equation. So the temperature, and I'll put here in degrees C, can be calculated by multiplying an adjusted Fahrenheit scale by a fraction of 5/9. Okay, so the adjustment to the Fahrenheit information lies within these square brackets. So one would input, at this point, the degrees F information, subtract 32 degrees F from that, and then multiply by 5 and divide by 9 to get the temperature in now Celsius. Okay. Another equation is one where we can go from degrees C now to degrees Kelvin. So the temperature in Kelvin units will equal the temperature in degrees C. Okay, so note that if we're presented with degrees Fahrenheit information and we need to go to degrees Kelvin, we're going to need to use both of these equations. We have to take that degrees Celsius information and add a value representative of the absolute zero origin for temperature. Okay, so this value is going to be 273.15 degrees. All right, so those are our two equations to help us convert temperature between the three different sets of units that are known in everyday and scientific literature. Okay, so let's look at an example now. An example might be, given a temperature of 54 degrees F, determine the temperature in degrees C and degrees F. Or degrees K, apologies. And in Kelvin. K. Okay. So maybe we'll call the first part A, and the second part B. So to address part A, we want to transform degrees Fahrenheit information into degrees F. So we're basically asked to do this. So we can inspect the two equations above and note that it's the blue one here, where if we're given degrees F that we can convert to degrees C. We could do vice versa with some algebra if another question was required, but we'll save that for another exercise. So this simpler version is simply going to be temperature that we intend to be in degrees C is going to be equal 5/9 times, now the temperature in Fahrenheit information, so this is 54 Fahrenheit degrees F minus the 32 degrees F. And that difference will be multiplied by 5. You'll see here now that putting some units into this, that we need to get into degrees C, and we're going to cancel degrees F. So not shown above for clarity were the unit cancellations, but clearly in the red square brackets here, the outcome is going to be degrees Fahrenheit. We need to cancel those units and inherit the numerator units that are degrees C, and that'll align with what we see here. So after having done this, you can see here that the outcome here will be 12 degrees C as the answer. Okay, perhaps you're wondering about significant figures at this point. What's in the parentheses here is a subtraction, so we would work with an answer that would have precision at the whole number, so at the value of the 4 or the 2. Okay, so I'm making note of the precision there, and then I multiply by this 5/9 fraction, which has infinite number of sig figs, okay? And so the outcome has to be to the whole number, and we would end at the 2 there for that. Okay, so 12 degrees C on that one. Part B. Part B told us to transform the information all the way into degrees Kelvin. Well, having answered part A, we can move forward and work with that information to help us in part B. Okay, so we want to use the degrees C information from above and go to the Kelvin scale. Okay, so our equation told us that temperature in units of Kelvin is going to be equal to the temperature in degrees C plus 273.15. Okay, and so this offset value of 273 shifts the temperature information to degrees K. So we're not able to show unit canceling in that regard. Okay, so in this case, we would work with the 12 degrees C, and we would offset that by 273.15 degrees, and this would give us a value of 285.15 Kelvin now for the temperature there. And thinking about significant figures, we report to the minimum. So the minimum here, we have a number with 2 digits here, and so because this is an addition or subtraction, we're not going to count significant figures but decimal point position. So we have 2, we're at the whole number there at the 2 position, and we have a value here that that has much more digits, well into the decimals, okay? And so this value actually keeps going with more precision in the experiments to determine the offset value for absolute 0, but clearly it's well into the decimal range. So the least amount here is the 12 with information to a level of precision at the 2 value of 12. And so we need to report out to that same level of precision in our answer. So the temperature here would be to the 5 position before the decimal point. So we're going to go to 285 K as our final answer there. Okay, and so this is how we convert temperature information using these 2 equations. We have not done more complex versions where we had to do some algebra ahead of time, but hopefully those steps are straightforward to you. For example, if you were provided with degrees C information, you would be responsible for knowing how to determine the degrees F information using algebra. And likewise, if you were provided degrees C and degrees K information, you'd be responsible for determining degree C through some algebra on that black equation at right.